Let's look at an example of using the definition of the derivative of a function at a point to find f prime of 2 for the following function. F of x equals 3x squared plus 2. So to start with, let's make sure we all understand what that definition of the derivative at a point is. Our f prime of a, or the derivative when x is equal to a, is equal to the limit as delta x approaches 0 of f of a plus delta x minus f of a over delta x. Now, in this example, the point that we're interested in is when x is equal to 2. So when we use this definition of the derivative, we will be focusing our attention at when a is equal to 2. So let's go ahead and get started. So what we're interested in doing is finding f prime at 2. So that will be the limit as x approaches, as delta x approaches 0, delta x approaches 0, of f of 2 plus delta x minus f of 2, all divided by delta x. Continuing, we'll have the limit as delta x approaches 0. Now I'm replacing every instance of x in my original function with 2 plus delta x. So this is going to be the quantity 3 times 2 plus delta x squared plus 2 minus f at 2. F at 2 is 3 times 2 squared plus 2. All over delta x. So continuing, we have the limit as delta x approaches 0 of 3 times 4 plus 4 delta x plus delta x squared plus 2. And then this second quantity is 3 times 4 plus 2. So that's 12 plus 2, or 14. All divided by delta x. Continuing, we have the limit as delta x approaches 0 of 12 plus 12 delta x plus 3 delta x squared plus 2 minus 14 all over delta x. Now, looking at this numerator, we see we have the constant 12 plus the constant 2 minus 14. That all sums to 0. We also notice that there is a common factor of delta x in the remaining terms, so we will factor that out. So we will have the limit as delta x approaches 0 of delta x times 12 plus 3 delta x, all divided by delta x. And now we have a product in the numerator divided by delta x in the denominator, so those can divide out. And what we end up with is the limit of, as delta x approaches 0, of 12 plus 3 delta x. Now, as delta x approaches 0, then 12 plus 3 delta x will approach 12 plus 3 times 0. Now notice that I kept the limit notation until I was ready to consider the behavior of the function I have here following my limit as delta x approaches 0. I must continue to use this notation of limit as delta x approaches 0 up to the point where I'm ready to consider the behavior of the function to the right. Once I'm ready to consider that behavior, I can drop this limit notation. So notice I said, now as delta x approaches 0, then 12 plus 3 delta x approaches 12 plus 3 times 0. Well, we can simplify that to 12. And so summarizing then, what we have here is that f prime of 2 equals 12.